Hey, hello, and welcome to the show. It is me, JP, and it is time for John Park's Workshop. And I'm sorry, I'm just noodling with the levels there because the audio was a little low on the last show on Tuesday. But I don't want to make this too high. So there we go. That should be good. Hello and welcome. Thanks for stopping by. Thanks for everyone over in our chats for jumping in. Hi over on YouTube. We got Robert Cochran, Dave Odessa, Badagraf Abdelhagen, Carl F. Hola. And if you're somewhere else, like Facebook, and you're wondering where the chat is, then you could check out our Discord over here at adafruit.it/Discord. That'll get you a link to go join our server, and that's the channel you want right there. Live broadcast chat, that's where people are hanging out during the show. Hi, John Nodge and Starman, Paul Cutler, hello, hey, Thin Man, Andy Calloway with the Lars Workshop, very upsetting logo. C. Grover, hello. Hey there. Hi. So, let's see. Robert Cochran says, hey, where can we find some code to play with? I'm on CircuitPython 10 Beta 2. Hey, all right. You're on a fresher one than I am. I'm on Beta 0, but we'll be doing a little tiny bit of code stuff here today. I don't know if you have a specific project in mind or just looking for something fun to play around with. We'll take a look at a little snippet in our CircuitPython Parsec segment. And what else have I got for you today? I've got a coupon code so you can save some money over in the shop. I have a recap of the product pick of the week from Tuesday. I've got the aforementioned CircuitPython Parsec. We'll be taking a look at a bit of ESP-NOW basics. Oh, look, I forgot. That reminds me to change the title of today's show. Let's fix that right now. ESP-NOW Basics. So this is going in slightly reverse order from when we did the juggling intro last week, intro to the ESP-NOW juggling project. So that'll come after this, but I'm going to do, lady Ada requested I do a little quickie get started guide on ESP-NOW. I'm almost done with it, actually. It'll just be how to get up and running, how to send stuff, how to receive stuff, how to transceive on one board, and peer-to-peer, peer-to-many, many-to-many, many-to-peer. You can do all those things with ESP-NOW, so we'll talk about some of that stuff today. I also have a little, I want to show you a little preview of the NES emulator running on RP2350. Latest version of that. It is on the Metro RP2350, but it'll be coming to the Fruit Jam soon enough. I've got my revision A prototype here, but I just ordered yesterday the latest. I think that might be revision D. Let's check that one out, actually. It's going to be coming in stock over the next few days and weeks, going in and out of stock. We had a small batch of them for sale yesterday. They went pretty quickly. You can find them over here. Go to adafruit.com. If you look on new products, view all new products, you'll see right there at the top, Fruit Jam Mini RP2350 computer. It's going to be $39.95. It's out of stock right now. You can click on, mine is already filled out, but you can click on a little email field there and it'll let you know when that comes into stock. Some nice changes since that revision A version. We're going to have ESP32C6, I believe, chip on there in the upper left corner so that we can do Wi-Fi stuff, co-processor style. Some spacing has changed, dropped the iSpy connector. There was nowhere to fit it, but I think we'll be able to use the I/O there, almost like a shield jack for doing display stuff. Real nice tall buttons on it. If you look from the side here, these are going to reach all the way up to the face plate or cases. You can see we've got a neat top plate that Lydia designed there. Some nice little shine-through FRF or FR4 shine-throughs on the NeoPixels on the left there. 5 little circles. You'll be able to see your NeoPixels shining through. Anyway, go sign up for that if you are interested. But otherwise, I'll say go any ways you want in new products, old products with this coupon code. If you want to save 10% in the store, now and later, now hyphen and hyphen later, now and later, just like the candy. Now and later will get you 10% off in the store today until midnight tonight. You just throw some stuff in your cart, and then on the way out, there's a coupon code field where you can type that in and get yourself some nice savings. That will work on things we can send you. It doesn't work on software or gift certificates or subscriptions, but it is good on physical stuff. And I think all physical stuff. I know at some point there were some restrictions on those. Those, I believe, have been lifted. I think Raspberry Pi and maybe some others. You can save on those as well. So get 10% off with that coupon code today till midnight tonight, now and later. Buy some neat stuff, build some cool things. Tell us about it. I hosted Show and Tell last night, and we had a couple of guests on. You should join us next Wednesday. Every Wednesday we do Show and Tell. It's at 7:30 p.m. Eastern Time in the U.S. And all you need to do is look for the link over in our Discord. We also have a blog post a couple times during that day. I think at noon you can find one and get set up, get prepped. You can just grab a webcam and a microphone and off you go, or you can, some people will set up a screen share with another screen, so you can try that stuff out and show us your projects, build some things. We'd love to know what you're working on. Let's see. Other thing I'll mention actually about the shop is you can save money with the coupon code. You can also save money by getting free stuff. I guess that's a way of saving money. Adafruit.com/free, and that will show you the deals we have on the different price breaks. If you go up to a $99 order, you will get a free Adafruit coaster. If you spend $149 or more, you'll get the free coaster, but you'll also get a KB2040 microcontroller board. Super excellent RP2040 drop-in replacement for Pro Micro. If you're doing keyboard projects, that's what it's particularly well tuned for. Also, if you go to $199 or more, you'll get the free coaster and the KB2040, but you'll also get free ground shipping in the continental United States with UPS. So those are some nice enticements. You can always find out what those are if you're unsure by going to adafruit.com/free. All that info is right there. Hey, let's take a question over in the chat. Let me bring back the Discord here. Question from Jane. Hello. I'm new in the programming world. I have just started learning Python, but before I have been learning Make, Code, and Scratch. Hey, that's great. I have base, but not so fully because of my teachers at school. Do you have some tips? What to do? Learn. I have classes about Python with a group. We've finished algorithms and some things that we use in Python, such as int, if else. Please help me. I want to pursue a career in programming. Well, I'll tell you what. We have some channels right here in our Discord that are about coding in CircuitPython, and I think that's a really nice way. If you just scroll down a bit, you'll see right there, help with CircuitPython. Go in there, ask questions, try things out. Look at any of our Learn guides that use CircuitPython. We have some tagged with, I think, beginner ones you might want to check out. My CircuitPython Parsec series, you can just go find that playlist on the Adafruit YouTube, and if you go all the way back to the beginning, you'll see I've started with some simple things and worked our way up. Yeah, but I think microcontroller is a really nice way to do that, to learn CircuitPython. Get a board with a lot of sensors and things on it, like a Circuit Playground Express, if we have those in stock right now, I'm not sure. Prop Maker Featherwing. Those have sensors and outputs and buttons and things, and you can learn about programming while doing physical computing things. Sensors and buttons, inputs, outputs, I think is a nice way to learn. Yeah, and as Andy Calloway says, welcome aboard. And if other people have suggestions on where to get started, get going with coding, please chime in over there on the Discord. Okay, well, let's take a look at my Tuesday show, which is the product pick of the week. On that show, I pick some new product, or sometimes an oldie but goodie, give you a nice big discount on it, show you a little demo. This week it was this PyCowBell, the HSTX DVI output. Here's a little recap. It is the HSTX DVI PyCowBell for Pico and Pico 2. It works best with Pico 2, RP2350, gives us speed, gives us RAM, and gives us dedicated pins for the HSTX peripheral that we can use to send video out over that mini HDMI connector. Yeah, I've got my HSTX DVI PicoBell connected here on this PicoBell tripler. HDMI cable into a little extender that I have, a little port extender. This tells me it's DVI in at 640, 480. And so this will cycle for 17 seconds was what I decided was the optimal demo time. Really neat diffusion, plasma demo. And then in a moment that'll switch out to the, there we go, the HSTX DVI video output PyCowBell for Pico 2 or Pico. Yep, that was it. Let us know what you do with them. And as I talk about some of this in a little bit, this Metro RP2350 and Fruit Jam mini computer stuff, emulator stuff, video game emulator stuff, computer emulators, I will say the HSTX Shield or PicoBell plus the RP2350 based Pico 2 also makes for a really formidable setup for a mini computer because we've got the video out over the HSTX DVI HDMI mini plug there. Also has USB host over PIO, and those are broken out, the D plus, D minus power and ground, so you can hook up a hub and get keyboard and mouse on there, or just if you just want to use a game controller, you don't need the hub. So hopefully some of these emulators that we're working on will also be ported to that neat little setup. If you plug one into the other, you get a really, really svelte package for a mini computer there. All right, let's take a look now at this week's CircuitPython Parsec. CircuitPython Parsec. Okay, for the CircuitPython Parsec today, I wanted to show you how you can find out the MAC address of your microcontroller right inside of CircuitPython. So for boards that do Wi-Fi, such as most all of the ESP32 based boards, this one happens to be ESP32S2 with the BME 280 temperature sensor built onto it. But any of these boards in particular, you're likely to do Wi-Fi stuff with them, or as I've been diving more into ESP-NOW, it uses that same chip, that same radio chip on there, and so knowing the MAC address is a unique identifier for that board that we can use to do things like peer-to-peer communications, authentication, other things like that. So on one of these boards, it's actually quite simple to find out the MAC address. I think in some cases it's on a sticker or stamped into the die, but I don't have that kind of eyesight, so, and I'm not sure on this one if it is. But if we want to find out the MAC address of this board, what we can do is, let me show you this from the console rather than running a full bit of code, so we can do it a line at a time. So here I am in the REPL. I'm on the board. The board is running CircuitPython 10 Beta 0. So I could update that, but this will work in pretty much any CircuitPython version. And you can see there the name of the board that we're on, Feather ESP32S2. So what I'm going to do is, first of all, import the Wi-Fi library. So import Wi-Fi. Next thing I'll do is enable the Wi-Fi radio. Wi-Fi.radio.enable equals true. Whoops. Wi-Fi dot radio enabled, past tense, enabled equals true, there we go. And now I can either just ask for the the Wi-Fi address straight out. I'm going to cast it to a variable, though. So I'll say MAC equals Wi-Fi radio dot MAC underscore address. Now I can print that variable out. So if I just do print MAC, we get a binary version of the MAC address, which I don't read that natively, so I'm going to turn that to hex. So I'm going to say, rather than the byte string, which I'm not going to read natively, I'll say, okay, print MAC. I'll make it a little fancier. Say MAC is colon, quote, comma, and then MAC, that variable that I grabbed, dot hex, parentheses, close paren. Oh, you can't see my typing. Hey, why is that? Something went wrong with, okay, I'll start this over again because, yeah, you absolutely can't see what I'm typing. What? Yeah, I don't think that's showing this one at all, is it? No. Oh, I have a weird phantom screen share there of a Z session that doesn't exist. Weird. Here's what I'll do. I'm going to quit Z. Yeah, that's weird. All right, we'll start this over again, but let me first add a new screen capture. Let's get rid of that one. Sorry about that. Okay, so new screen capture. Bear with me for a moment while we go into the black hole. And I'll launch Z again. Z just happens to be my code editor. Here, let me tell my broadcast software to point at that screen. Sure. Okay. That looks better. Okay, and let's bring up a new REPL. Okay, so you'll see this really for you up there. Okay, pull that off to the side. Here we go. Much, much better. Yes, yes, yes. Thank you for letting me know, Starman and Andy Calloway, that wasn't showing up. Okay, so let's do that from scratch. For the CircuitPython Parsec today, I wanted to show you how you can get the MAC address of your board that has a Wi-Fi radio built on it. This is particularly helpful for things like ESP32 boards, especially as I've been using ESP-NOW lately, but any Wi-Fi chip on a board, you're going to want to sometimes find out the MAC address so that you can do things like authentication or peer-to-peer networking to one particular board. This is a unique identifier for this board's Wi-Fi chip. So what I'm going to do is over in the REPL, I'm going to first of all, I'll use Disco tool, and there's many ways you can do this, but I'm going to get to the REPL of this Feather. This is a Feather ESP32S2 that I have plugged in here. So that's connecting, and then I'm going to go hit Control-C to get right to the REPL here. So now I can enter code directly into CircuitPython on the board. So the first thing I'm going to do is I will import. Oh, wow, someone said the audio is now out of sync. Huh. Let me know if that's the case for everyone, or crossing fingers it's a YouTube issue. I see a lot of people typing, so probably there is a sync issue. Oh, no, audio sync on YouTube is okay. Not sure, Andy, if you're watching it somewhere else, but let me know. Okay, so let me continue that. So the first thing I'm going to do is import Wi-Fi. That's the Wi-Fi library into the board. And then I'm going to enable the Wi-Fi radio. So I'll do Wi-Fi.radio.enabled equals true. So this turns on the radio. Now I can ask it for its MAC address. Now I can simply just print that out. If I do print Wi-Fi.radio.MAC_address, that will give me the address in bytes, which is a little awkward to look at. I want to see this in hex, which is what we're used to dealing with for a MAC address. So what I can do is I'll make a variable for this. I'll say MAC equals Wi-Fi radio MAC address. Now, instead of just printing the MAC address, I'm going to print a hex converted version of it. So I can format this in hex by simply doing print mac.hex. And there you can see the MAC address on this board is 7C-DF-A1-94-AE26. And that is a useful way of looking at it. You can also get a little fancier, actually have a bit of code that I already created, so you don't have to watch me type it in real time, that will use some string formatting, F-string formatting, to make it uppercase and put some colons between every two characters. So that's a very familiar MAC address style right there. And so that is how you can get the MAC address of your Wi-Fi capable board inside of CircuitPython. And that's your CircuitPython Parsec. And thank you over in the chat. Some people suggested to Andy to refresh YouTube, and that fixed an audio echo problem. Weird. Don't know why that happened. Robert Cochran says also the MAC address of the device is printed in the CircuitPy boot.out.txt. So there's a couple places that you can get that. And the reason that I'm actually using this method of doing it inside of code is for some of the ESP-NOW stuff. I want to be able to find out the MAC address of a board so that I can then target sending messages to it directly. So you'll see me expanding on that as I work on this juggling balls project that does ESP-NOW communication among balls. Phew, all right. Dave Odessa also in the chat said over on YouTube chat that they were out of sync. So hopefully if you can refresh, like shift reload your browser window with YouTube in it, you should get that back in sync. All right, let's move on then. What do I have? I've got a few things I want to show. Let's start with that over there. That's kind of fun. So let me show you what we're looking at. I'm gonna let me zoom. I'll stay over here for a second while I talk about what this is. Get a little closer and get some focus on there. So the board I have here, this is the Metro RP2350. In fact, I'm gonna head over there. Let me head over there. So Metro RP2350 has the Raspberry Pi RP2350 chip on it, as the name suggests. And then I've got, wow, that is a bright light. Hold on. I was moving lights around yesterday. Hey, this one's Bluetooth though, so I can calm that one down. Hold on. Better. It's still bright. I need a filter on that one. There we go. So Metro RP2350, we've got an HSTX out on there. Let me grab a pencil to point with here. And then I'm using this flex cable to connect that to an HDMI-shaped DVI video output. You can see right there. That cable is actually running to a monitor over there. So we'll turn this on and I'll grab the controller. The board is running the Pico Nest firmware that Frank Hodemaker is working on. We've done some other Pico Nest stuff before, and ultimately we're going to get this all running on the Fruit Jam as well, which will be a really nice, convenient format. We can plug controllers, two USB game controllers into it, HDMI right out of it. Audio can come out over this the DAC headphone output, or we can use an onboard speaker if we're doing a more mobile thing. And excuse me, in this case, you'll see I've got a USB SNES style controller plugged into these USB host breakouts for the PIOs. That's on the board there, just as 4 pins. So I soldered some headers to those. I've also got a, let's see right here, WeChuck adapter that gives us I2C, just like the original Wii, Nintendo Wii remote, nunchuck, and other accessories. They use this I2C breakout. So I have that plugged into the Stemma QT port, and into that I have one of these nice official Nintendo Classic controllers that came with a little mini console. There's a few different ones. If you had a Wii and got that Wii Classic controller, that'll work because they all use that same lovely little connector there, the WiiChuck adapter connector. So what this will give me is two-player gaming on the RP2350 on a NES emulator, Nintendo Entertainment System emulator, Famicom if you're from that part of the world. And one controller is plugged in over USB, the other in this case is over the Stemma QT. But on the Fruit Jam, we should be able to do both of those over USB. We also do still have the Stemma QT port, so you'll have options. So with this plugged in, I'm gonna step back over to that station over there and turn on the TV. You can see this in action. And this is not the latest, but close to the latest. Actually, I think this is the latest cut of this for the Metro RP2350. I do not have sound on this version, but that'll be coming soon. So this is just a HDMI connector here. I'm running Galaga on there right now, and so this is the USB connector there. I'm going to turn off that light there because there's a big glare. But you can see if I hit select and start Info NES, Pico Info NES Plus, this has a little file browser for the ROMs that you've put on the SD card. So if we go to the classic Super Mario Brothers, I can hit start there. And you probably can't see it too well on here. You'll just see a brightness change probably. If I hit select and up, we can go to pixel perfect mode. If I hit select and up a second time, we're going to scan line mode. So every other line is darkened a bit to look a little more like a CRT, which is kind of nice. I do like that it gives us a bit of that look, even though this is a HDMI output. So here you go. We got Mario. He's nice and responsive here. I'll probably just die immediately, but boing, boing, boing. You can supply your own sound effects. Get tired of that, hit select and start, and then go start up some other game here. How about Micro Mages, my fave? Make that brighter. One player. And there we go, our little Micro Mage. Wee! Everybody wee! So I'll let his time run out. So this is running on the Metro RP2350. I wanted to show you where you can go check this out if you're interested, as well as our original collaboration and work on this. Let me go to GitHub, and this is, I'm going to put this in the chat over on Discord. Fhodemakers Pico-InfoNES Plus, and this is building on someone's work, so it's been a big open source collaborative project. Emulator is InfoNES by Jay Kumagata, and then there was ported to the Pico by Suichi Takano, and then Frank did work to get this on the Piberoni Pico DV base, the Feather RP2040 with DVI. He also, I think, did the menuing system. We had some help from Phil Burgess doing, I think, the real controllers, official controllers. If you get, what's the word I'm looking for? Shift register based control on some pins using an NES or SNES controller, and on and on. So this has kind of gone through a few revisions, and now Frank's been doing a lot of work to get this really kicking butt on RP2350 and get it prepped for the Fruit Jam, including the I2S audio DAC. So we just sent one to Frank when we had a few in stock yesterday, so hopefully he'll be able to start getting that in working order, and we'll have a really nice little compact emulator with no added doodads and parts on it. You can see we'll go from this sort of thing here, which there's a DAC that I was using for a different project, but to that. So that'll be a lovely improvement, I think. So that's what's going on with that project. Other info, other things I wanted to jump into today. Let's talk about the ESP-NOW basics, because this is foundational stuff that I've been learning to work on this juggling balls project. So I'm going to go back to a down shooter here, and let me plug in. What I've got here are 2 feather boards, and I am way zoomed in. Hold on. Fix that there. Turn this light here back on, and sorry about that little glare on this second board. I'll be able to lift it like that a bit. So let me pull the camera out a little bit more so you can see. Let me go full screen on this, what we're talking about. So here I've got, yeah, that's a little better. We'll talk about code in a second. Here I've got 2 feather boards. They're both ESP32. These happen to be S2, but this will work on S3 boards. These are a TFT feather and a reverse TFT feather. It's just what I happen to have handy. You can see this one's screen adhesive has come off a bit. Do I have any tape right here? I don't think so. So this one's popping up a little bit. Now these are wired in the sense that I just have power and data over USB on this one, so we'll be able to look at it in code. This one actually, I've been charging a pretty hefty LiPo, so that one's just on the LiPo. These are sitting right next to each other, which makes no sense because this is all about wireless, all about ESP-NOW. But I just wanted to make them behave as I show them and have them sit together on my desk. And what you can see here is I have a little text at the top that says ESP-NOW board A, ESP-NOW board B. Press the D0 button to send. So this button on the reverse TFT feather wing is the D0. When I press that, you can see it says transmitted, and this is just how many, I've got a counter here, sorry, a counter here. So every time I transmit, that's going to iterate or increment that number. So transmitted 6, 7, 8, 9. So I'm sending that number as well as just the fact that a message is going from this board to this board. Over here, I'm keeping track of a couple of things. I've got the color of the board that's sending. So unfortunately, I'm using white on this one and blue. I'll change that in a second. But the blue color is the transmitted, and over here you can see the blue color is the received. This is board B, and it's sent over to board A, and that number 9 is in sync between them. Oh, you can see that's why when I plugged in this other feather for the demo in CircuitPython Parsec, it was running some code that was also just broadcasting out to anyone listening. And so I got this is the BME's pressure reading right here. So if I come over here and press the equivalent to the D0 button on this regular TFT feather, you'll see same thing on this guy. He's saying, oh, you're getting board A, and the number here. Let me go ahead and focus this a bit better. Better, sharper. So also now the color is nicer. I thought I had picked a better color. So there we go. This one's every time we send, and you can see you can send rapidly. You can send both boards at the same time, as long as it's not the same time, but I'm not likely to ever do that. They'll be a little bit off. we're receiving the number from the board that it's sending, as well as the identification, board ID, which I'm just calling this board A, board B, board C, D, E, as many as we want, and the color value of the, I believe the color value is in CircuitPython locally, not being sent across. I could be wrong on that. I don't think so. So how does all this work? So this is, as I've talked about ESP-NOW a little bit, ESP-NOW is this connectionless, does not use a hub, does not use a Wi-Fi router, does not use a lot of the stack and a lot of the things that can benefit computers doing complicated things, but can slow down microcontrollers doing simple things. Sends up to 250 bytes, small little packet. Sends it really fast, and it sends it 100 to 200 feet in the open air. So it's got a nice range to it, and that's just with these little onboard antennas like this one you see here, this little PCB antenna, that little squiggly there. There are boards that also have external antennas, especially useful for a receiver board, like I was doing with the juggling project last week. And let's talk about peer-to-peer and multi or broadcasting. So I'm going to take a look at my code here, get rid of extra me, there we go. And let me open up the code.py running on this board A over here. Did that open? Am I going to have to create a new? Yeah, I've got weird Z behavior. Okay, let me quit that again and relaunch. I'm not sure what's causing that. Let me open the code.py. Oh, it's angry. Why? It won't open. Weird. Let me transfer it off of the CircuitPy drive first, just to see if that's causing it problems. Maybe Z just is having issues. You know what? Right before the show, I hit the, yeah, go ahead and update Z. I wonder if I made a mistake in doing that. I wonder if this version is having some problems. So I just moved my code to the desktop. Let me go grab that copy. It will not. Okay, let me launch Sublime Text instead. It just asked update available. I was like, no thanks, I don't want that. Cancel this. I close a couple of old things that showed up. And then I'll share this screen in a moment. Thanks for your patience. Let's see if I can grab it off the board. Sure can. Yeah, okay, I think I made a mistake in updating Z right before the show. Let me share this window with you. What is your name? Sublime Text. There you are. Oop, okay. It'll look a little different, but there it is. So this is a, what I'm doing on here is a transceiver. I'm going to go a little backwards here. I'm going to show you this, then I'm going to back way out to just a simple example of sending and a simple example of receiving, just to solidify that. But we can see in here is I'm importing Wi-Fi and I'm importing ESP-NOW. Just like we did when I was looking at the MAC address, we're going to enable Wi-Fi, turn on that Wi-Fi radio. We actually start an access point right here so that we can set it to channel 6, which is the Wi-Fi channel that ESP-NOW operates on. I'm setting the max connections to unlimited by saying 0 there. And then I turn it off, but that has triggered that change of channel for the radio. So we're in the, we're all in this same spectrum, same frequency for the ESP-NOW. You can see some of the stuff I showed here for formatting bytes so that I can read what comes back as MAC addresses in case I want to send to just one device or I only want to receive from certain devices. However, in this case, I'm sending to any ESP-NOW device listening, and the way I'm doing that is by creating the ESP-NOW object. I'm just naming it E. E equals ESP-NOW.ESP-NOW. And then I'm making this peer, which is an open MAC address. It's basically 0000000. Also, again, you can see I'm saying it's on channel 6. So when I append that to the peers list, this board, this first board here, knows that it should send to every peer in that list. This peer list happens to be the catch-all. However, we could add 2, 3, 10 very specific MAC addresses we want to send to here just by appending those to this peer list and then either iterating through and sending to all of them or sending to just one specific one. Wait, did someone catch my typo again? Why do I have these funny typos with this? Transceiver. Thank you, eagle-eyed Dave Odessa. Transceiver demo. So this is the main setup here for ESP-NOW. Again, you can see just to find out the MAC address when I boot it up so that I can use that if I want to later. I just have a little convenience there. And then I set up some colors here for sending. So I actually, in this demo, I'm just saying here's the 4 boards I might use and the color that they'll send their text in. So I am getting that sender color from the message. I'm pulling that out. I'm doing some display I/O stuff up here just to make the screen, some button debouncing setup. But then the main loop of it is checking for button presses. And if it's pressed, we iterate that message count number. And then we have a message constructed, which is the device ID, which is board A in this case, and message count. Sorry, Andy Calloway asked, FF is 0? No, it is not. It's FF. I guess that's 16. So yeah, the MAC address of FF, not of 0. Thank you. That's the open one. That last number available is the MAC address that says we're sending to everyone. Thank you for the clarification. So then when we press the button, we iterate, we construct the message, and then we try to send the message. So message, comma, peer. This, by the way, is something that I caught myself on a few times, which was forgetting to include that peer, who are we sending to, because I was thinking, oh, I'm sending to everyone. You'll get a kind of obscure ESP-NOW error, I believe, if you try that. This is what's missing 9 times out of 10. Then we update the board to say, I've transmitted that iterated number in our proper board color, and the message is sent. Then we're also, since this is a transceiver, we're also checking for messages. So if there's activity in the ESP-NOW radio, the packet is the variable I'm casting to eRead. E.read says read an incoming message. If there is a packet, then we are grabbing the sender's MAC address, because that comes along with it. So we can say, oh, I got this message from this MAC address, which you may use in code that's updating its peer list, maybe. And then if it's a message that we can unpack, we will say packet message decode, and then print that message here, in this case, board B, and the number 34 goes to the screen, and then we have a small delay. So let me open up a couple of simpler examples that are just send in one board and receive in the other. So I'm gonna, let me go grab those. ESP-NOW basics, sender, receiver. So here, let's look at the receiver first. So same sort of thing. I've got Wi-Fi and ESP-NOW imported. I set channel 6 on Wi-Fi and then turn off that access point. Create the ESP-NOW object. Find out my own MAC address if I need it later, but this is, in this case, not used. And then I wait for packets. So when I get a packet, same thing. Packet is e.read. And the message decode right here, decoded message equals packet.message decode, and then to UTF-8. Then I print out what came from it. So The sender is almost identical, but in this case, I'm not doing the complication of the transceiver, so I think this is a nice one to get started on. This is what's going to be kind of the first code page in the guide that I'm writing. I'm almost done with it. It should be out in a couple days. That shows you, okay, just get 2 boards, get CircuitPython on them, put the sender on one, receiver on the other. You don't even need to import any library, or rather, you don't need to get any libraries to put on the board. They're built into, both Wi-Fi and ESP-NOW are built into these boards, into the CircuitPython. They're baked into it, or frozen into it, I think we call it. And you'll be able to send from one and receive from the other. So this one just tries every 2 seconds to send a message, and that message is, in this case, hello everyone, and we'll just receive that on the other side. So that is the fundamental of that. This is this little demo here. I'll reset these 2 boards. Go to full screen on that. Okay, you can see this from scratch. By the way, one thing I learned is that the boot button is D0 on a lot of these boards. So even though I was using 2 different boards, one which has a CircuitPython board D0, the other has a CircuitPython board dot button, you can also call it D0 on this one. So if you're using D0 on the regular TFT, it's the same as the D0 on the reverse TFT. This one's actually labeled boot, but after you get through boot, you can use that second button right there as the D0 button. Boop, just like that. Move my camera a little. As you probably saw before, if I plug in this other one that's transmitting, this is kind of a case for why you might include MAC addresses, is you don't want to pollute things. So if I broadcast to everybody, this one every 3 seconds or something is going to transmit the temperature, pressure, and humidity off of the BME 280 that's on here. So you can see I can still get messages from this board, but then this one's going to send I think it's every second. So I can see there all messages are flying in from all over the place. So ultimately, for the juggling ball project, I will check the MAC addresses and just put them in peer lists. The balls won't actually, I don't think I'll plan to have them send info to each other. They'll just send it back to the base station, which is going to play MIDI sounds. If I do any coordination among them for color stuff, then they will talk to each other. But again, we can have a little peer list for that. Oh, here's a really good question. So Retired Wizard asked, will ESP-NOW run on the FruitJam Wi-Fi coprocessor? Such a good question, and I don't know the answer, but let's see if I can find that out right here. So I think it's a C6. Let me look at that. Let me look at that product page. ESP32C6. So now I'm just going to check ESP-NOW for ESP32C6. The question mark's implied. Guessing yes. Yeah, so this is the C6 board page from Espressif, and it looks like that ESP-NOW is included on that. Yeah, really good question. I hadn't thought of that, but that could be really fun to do some stuff where you can see data that's coming over the little ESP-NOW network for sensors, little inputs, show up on a nice HDMI screen with your FruitJam. So I won't promise this will work because I haven't tried it yet, but it's a pretty good chance it should. I can't imagine why it wouldn't. So thanks, Retired Wizard. Excellent question. All right. Let's see. I think that covers everything I planned to show today. Let me know again over in the chats if you have questions. oh, here's one. Ed Schaller says, last time I did a microcontroller project, I got wrapped around the axle doing debouncing the buttons. I'm not seeing how you're handling that here, but I'm not seeing issues with bouncing. Okay, so this is a really good question. In this case here, it's a pretty simple method of debouncing, which is I've got a variable called last button time. I've got a button debounce amount, which is 0.2 seconds or 200 milliseconds. When I press a button, we check to see if that amount of time has elapsed since the last time. So the first time this is pressed, it's going to definitely enough time has elapsed. But then we mark down at the end of this the last button time is equal to the current time. So that just grabs the current time monotonic off of the microcontroller, and then when I press it, we have to make sure that 0.2 seconds have gone by. That's a nice, straightforward way to do it. I've actually done some CircuitPythons on a couple of other ways. One is there's a debounce library that's really convenient to use. That also allows you to do some long presses and double presses and stuff. Other way I really like to do it is with the keypad library, which has debouncing built into it. So look for the Learn Guide on keypad, or look for debounce. And we have Learn Guides on those. We also, like I said, I have some CircuitPython Parsecs. Great question. Thanks, Ed. Someone said, lol, wrapped around the axle. I like that expression. Never heard it before. I haven't heard that in a long time. My buddy's dad growing up, Steve, who worked on cars a lot, he loved that phrase. Yeah. All right, other questions? Foamy Guy says, the chip is capable of it. So this is back to the question of, do we think we'll have ESP-NOW available on the Fruit Jam? Chip is capable, but I think it will depend on whether Nina firmware and ESP32 SPI libraries have support for ESP-NOW to work in CircuitPython on the Fruit Jam. Yeah, okay, so there are things I don't know about that either, so we'll wait and see. Chip can, but will the rest of it support that? Not sure. All right, I think that is going to do it. I will say, what's the date here? The 31st. Okay, so I think on the 4th, the episode of Bootloader podcast with Paul Cutler and Todd Kurt that I was a guest on, we recorded that last week. I think that podcast comes out maybe on the 4th of August. If you listen to that and you're interested, it's a show where you bring on a couple of suggestions, and I've actually got the things that I talked about. Here's a teaser. Floppy disk, boombox, and something else that's over there on the workbench. I'll probably show those next week after that as aired, so that you can see video, because that is an audio-only podcast. So that's a little tease for some stuff to come. Yeah, and Paul, thank you, over in the chat, confirms the 4th, Monday the 4th is when that'll be out. So next Thursday, I'll probably do a little show and tell on video. Okay, so I'll remind you, if you do want to go out and get some cool stuff, build some of these things that you've seen here today, maybe grab some ESP32 stuff, maybe a Metro RP2350, who knows. But don't pay full price. We want to give you a little discount. We want to give you 10% off with Now and Later right there. That's going to get you 10% off. Just type that in the coupon code field on the way out. And also don't forget the enticements. If you spend more, we know shipping is a lot. We know your hard-earned money is precious. If you do want to buy some stuff from us, that's awesome. Helps us keep going, keep the lights on, keep us doing the things we're doing. But save a little bit of money. So Now and Later, now, hyphen, and, hyphen, later. That'll get you 10% off. Anything else? I think that's it. I'm just going to scroll back to make sure. Sometimes after the show, I realize someone asked a big, important question that I failed to see. So let me scroll back in the two chats. Oh, Dave Odessa. Yeah, I said, what happened to that radio that was on your workbench on Tuesday? That's there, right there. I'll play it. I'll play a demo next week. And over in our chat here, some people giving some answers to Jane about programming. Thanks for chiming in. Good. All right. I think that's going to cover it. Thanks everyone so much. I believe we've got a deep dive with Foamy Guy tomorrow, and there should be some Lady Ada, Desk of Lady Ada, and PT videos over the weekend. We'll be back on Tuesday with another product pick of the week. I think I have a fun one. I know the product is fun, but I think I have a fun build in mind for the demo. Wednesday morning, 3D Hangouts. Wednesday evening, show and tell. Please come on by and show your stuff. Tell. Wednesday evening, Ask an Engineer, and then I'll be back with John Park's Workshop. So thanks everyone so much for coming by. I'm going to get out of here for Adafruit Industries. I'm John Park. This has been John Park's Workshop. Bye-bye.